Here we're going to look at isotopes. We've already talked about isotopic notation and briefly introduced isotopes earlier in the course, but we're going to go more in depth here. An isotope, as a refresher, is an atom of the same element, meaning it has the same number of protons and therefore the same atomic number. So it's an isotope is an atom of the same element with a different number of neutrons. So the only thing we're changing here with isotopes is the number of neutrons. Now when we change the number of neutrons, that results in a different mass number, because remember, I drew a little mediocre looking arrow right here to show you. Remember that this number right here, the mass number, is a result of protons plus neutrons. So when we change the number of neutrons, we're changing the mass number. Now it's important to note that protons within a certain element never change. Anytime we're talking about carbon, you look at the periodic table, its atomic number is 6. Carbon will always have 6 protons, always. But if we change the number of neutrons, it's going to change its mass number. Let's look at these examples of isotopes of carbon right here. If you look at the periodic table, you'll see that carbon has an atomic number of 6. That will never change. It has a mass number of 12. So you'll note right away, if there's 6, its atomic number is 6, its mass number is 12, it must have 6 protons and 6 neutrons. Now, in an isotope, we will change the mass number, and that is coming as a result of a change in the number of neutrons, because protons will never ever change. So if you see carbon 13, you know that protons plus neutrons have to equal 13. You know it's going to have 6 protons, so that must mean now it has 7 neutrons. And then we look at carbon 14. Again, we are changing the mass number, and that's because now we have 8 neutrons. 6 plus 8 equals 14. So these are all the same element. They're just different isotopes because we've changed the number of neutrons, which therefore changed the mass number. So that is isotopes, what an isotope is, and some examples right there of isotopes of carbon. The most stable version of an element is the version found on the periodic table, meaning carbon has a mass number of 12 and an atomic number of 6 on the periodic table, meaning it has 6 protons and 6 neutrons. That is the most stable version of carbon. That's the version of carbon that occurs most in nature. If you add or take away neutrons, causing the mass number of carbon to change, then carbon can become unstable. So these two isotopes of carbon may be unstable, whereas this here would be stable because this is what we see on the periodic table. Remember, this is changing because we are changing the number of neutrons. The mass number is changing. All right, we're going to look at some example problems. If you feel like you got it already, you can pause this, solve these, and move on. If not, you should watch me solve some of these. So how are nitrogen 14, 15, and 16 different? Well, first of all, is to remember our mass notation. And in mass notation, this number right here represents the mass number of an element, right? And mass number, I'll put up here, remember mass number equals protons plus neutrons, right there. Mass numbers are protons plus our neutrons. We also remember that protons never change as long as you have the same element, meaning nitrogen right here. Let's look at the periodic table. Nitrogen has 7 protons, always, and that will never change. Well, then how is this number changing? What is going on? How are these 3 types of nitrogen different? If they all have 7 protons, why do they have different masses? They have different masses because we are changing the number of neutrons. So this nitrogen 14 would have 7 neutrons. Nitrogen 15 would have 8 neutrons, and nitrogen 16 would have 9 neutrons. I'm just getting that by doing 16, 15, and 14 minus 7 because this is the number of protons and that never changes. So these are different because they have different numbers of neutrons. Number 2, how many neutrons are found in oxygen 17? Well, if we look at oxygen, we'll see that oxygen's atomic number, the number of protons, is 8. If its mass number is 17, in order to solve for the number of neutrons, we would do, we would do 17 minus 8. And that is going to give us the appropriate number of neutrons, which in this situation would be 9. Okay, number 3, how many protons are found in neon 22? Do protons ever change in an element? No. They do not. So to solve this, we actually don't even have to look at the mass number. We just need to find the atomic number of neon, because the atomic number of neon will tell us the number of protons. So I look at neon, I see that its atomic number is 10, so it has 10 protons. We only look at this if we need neutrons. All right, finally, our last question here. Based on isotopic notation, remember isotopic notation? Mass number on top, atomic number on bottom. Which of the following are the same element? So the E just represents like a hidden element. Which of these two elements would be the same? Are we going to look at mass number or atomic number? Which one never changes? Atomic number. We don't want to look at mass number, so we don't need to pay any attention to these numbers on top if we're looking for which element is the same. We want to look at the numbers on bottom. Whichever elements have the same numbers on bottom, those are going to be the same element. So we look here. This has, there we go. This has an atomic number of 2, and this has an atomic number of 2. What that means is each of those elements is helium, because helium has an atomic number of 2 and will always have an atomic number of 2. So that's a basic synopsis of isotopes, elements or atoms of the same element that have different mass numbers due to a different number of neutrons. Good luck. Farewell.